Very good morning. I am here to present our paper Forgery Direction in Image Colorization. Basically, there are many advanced tools available that can create a realistic image. So our target is to differentiate between the real image and the fake image. And we are more focusing on the image colorization issue because there are many tools available now that can differentiate that can convert the grayscale image into colorized image, but it is very difficult to analyze that it is natural color or artificial color. And there are two major approaches for detection: machine learning based and deep learning based. Basically, the realm of digital image forensics can be divided into many domains. Like image forgery has copy move forgery and image splicing. Also, the other part are image retouching, image colorization, computer generated images, and anti-forensics. Basically, these part cover under the passive. And for active, generally we use the digital watermark and data signature. But the problem with the watermark signature is that the receiver should have the proper information about the image. But it is practically impossible in social media cases or where source is not defined. And other part is the, as I discussed, copy move and splicing forgery. In copy move forgery, basically the same image is used to make the fake image. As we can see in the picture, some part of the image is copied from that image and to create a fake image, so it looks very realistic. There are many deep learning models and machine learning models available to detect it. Splicing is very similar, but we use generally different set of images to create the fake image. So it is generally found that splicing is easier to detect than copy move forgery. And also sometime we use retouching to enhance our images. We generally use in our mobile phones. Also, to make the fake images, many type of geometric changes are applied. So it is very useful if we want to analyze the image. What are the operations are performed on the image? It helps to detect the images. It can be detected by frequency analysis, discrete cosine transform, machine learning techniques. Here is one example in which left image is taken from the camera and right image is generated from the computer. So you can say that it is very difficult to find the computer generated images. And in next slide we have discussed about the CGI. CGI is generally called the computer generated images, and generally now we are using GAN model to use computer generated images to create the computer generated images. And for the camera identification, generally the metadata and the noise pattern of the sensor is used to differentiate between the original and fake image. Generally for this process we use the acquisition process of the image. The different steps help to differentiate between the two type of images that is useful to find the camera of the image. Basically, anti-forensic is used to hide the traces of the manipulations. So many advanced techniques are available in which the GAN is the most prominent now. But the benefit is that when you want to hide the traces, there are more traces of anti-forensics. So sometimes it helps, but sometimes it does not. So we should have the techniques for anti-forensics also. So basically, forensic and anti-forensic is like virus and antivirus. Basically, image colorization is generally used to color the black and white or grayscale images, historical images. But sometimes the purpose is malicious. For example, the picture is very old and some people is used in the colored version to mislead the people, like in journalism, law, and medicine. So it can confuse the layman or even the scientist what is the real image or what is the fake image. And two major detection methods are the machine learning and deep learning. Deep learning methods are also called end-to-end methods. The challenges are the methods are so robust that it is very difficult to differentiate between the colored image and the natural color image and colorized images. And also the creation process and multiple databases are available, so it is a little challenging. Here it is a simple model in which first part of the diagram show the conventional detection process in which generally we did pre-processing, feature extraction, feature selection, and after that we applied some classifier to classify the two type of images. And in the deep learning model, we generally input the image and directly we found the output. But we need to define the steps for better utilization of deep learning model, like how many layers we need. And generally we use softmax classifier, but we can also use different classifier. So basically, in deep learning method, there are a lot of filters through layers. We use them to differentiate between two type of images. In traditional methods, local binary pattern and also the hue saturation of the colorized image is generally useful to differentiate between the colorized and non-colorized image, the colorized and natural colorized image, and also the inter-channel correlation, and also the advanced version of local binary pattern are generally used for differentiating the images. But generally, when there is comparison and different data set, these techniques did not give better results. And deep learning based, generally we use end-to-end model as I discussed earlier. And there are many type of models that are used, like two-stream CNN, in which we use the spatial and frequency both features, and also using ResNet, DashNet hybrid models. And these models generally find better generalization, but the cost of computation is very high for these deep learning models because the size of the image is big, and also to better result we need to use the many layers that increase the complexity of the model. So traditional models are like LBP, histogram, correlation. It is lower generalization capability and also more sensitivity to compression and artifacts. But the deep learning model is end-to-end learning model, better at identifying subtle color inconsistencies, improve robustness, demands higher computation resources and label data. The challenge is there is no single particular data set that we can make some model that is applicable to other data sets. And there are many recoloring techniques and also more techniques are coming, so it is very difficult. Also, there are adversarial attack on forensic tools. So we can create the GAN-aware detection strategy, improved interpretability of DL models, standardized benchmark for fair comparison, integration into media authentication pipeline. By using these future direction, we can improve the detection. So, image colorization forgery pose serious ethical risks. Ongoing research needed for robust detection tools, combating misinformation and ensuring image integrity, transparency, and data watermark are the key solution.